Here students, I explain in this video frequency response plots. What are the different types of frequency response plots to calculate the frequency response of a given open loop and closed loop systems. So the frequency response plots are total 5 plots will be there. So first 3 plots are Bode plot, polar or Nyquist plot, Nicholas plot, and fourth one is M and N circles, fifth one is Nicholas chart. So total 5 different plots will be there to calculate the frequency response of a given open loop and closed loop systems. But what are the methods to calculate the frequency response of open loop systems? What are the methods to calculate the frequency response of a closed loop systems? First 3 methods are used to calculate the frequency response of a open loop system. Bode plot, polar plot or Nyquist plot, Nicholas plots. These 3 are used to calculate frequency response of a open loop system. These 3. And M and N circles and Nicholas chart. These 2 are used to calculate the closed loop system frequency response. So that first 3 methods are used to calculate the open loop system frequency response, and fourth and fifth methods are used to calculate the frequency response of a closed loop system. The frequency response plots are used to determine the frequency domain specifications, to study the stability of the system, and to adjust the gain of the system to satisfy the desired specifications. For this purpose, we are using the frequency response plots. So that means specifications and stability and gain adjustment and desired specifications. For these purposes, we are drawn the frequency response plots. So first plot is Bode plot. The Bode plot is the frequency response plot of the transfer function of a system. A Bode plot consists of 2 graphs. This is very important. A Bode plot consists of 2 graphs. One is a plot of a magnitude of a sinusoidal transfer function versus log omega. So that one graph is magnitude versus log omega, that is the one graph. The another graph is phase versus log omega. So that magnitude versus log omega is one graph. Second one is phase angle versus log omega is the second graph. Combination of or the combining of these 2 graphs is nothing but Bode plot. So that if you want to draw the Bode plot for a given system, we can draw the magnitude plot and phase plot. Both are combined together, then the Bode plot completed. The main advantage of the Bode plot is that multiplication of the magnitudes can be converted into the additions. So this is the major advantage of Bode plot. That means multiplications of magnitudes can be converted into additions. What is the important while we are converting multiplications into the additions? So consider the example. We can multiply 345 into 475. Is difficult, or add 345 475. So these two numbers adding is very easy than compared to the multiplication. Like that, multiplications can be converted into the additions. That is very easy to add. So that is the main advantage of Bode plot. So in Bode plot, all multiplications are converted into the additions. That is the main advantage of Bode plot. In Bode plot, so what are the graphs required and how can you split the graphs in Bode plot? So this is the model graph for Bode plot. So the Bode plot required semi-log graph. This is the semi-log graph. So that if you want to draw the Bode plot for a given system, the semi-log graphs are required. And this is the x-axis, this is y-axis. In x-axis we can take as log omega values, and y-axis we can take 2 different values, magnitudes as well as phase. So this total graph can be split into the 2 parts, exactly half. Above part can be drawn for the magnitude, below part can be drawn for the phase, and for the magnitude and phase for both the x-axis value is the same, that is log omega, and this graph can be divided or splitted as decades. So 10 different values are nothing but one decade. Here 1, 2, 3, 4, 5 and so on 9. Total 10 different values is nothing but decade. This is one decade, second decade, third decade. In Bode plot, the characteristics are changed according to the decays. So for decay we can expect changes in Bode plot. So in Bode plot the statements are minus 3 dB per decay, like that. That means one decay minus 3 dB magnitude is changed. That means, so initially we can draw or we can identify the decays in Bode plot. Decay means 10 different values. 10 different values are nothing but decay. So the 10 different values are nothing but decade, decay 1, decay 2, decay 3, decay 4 and so on, like that. So initially we can split the semi-log graph like this. In x-axis log omega and y-axis both are taken. So magnitudes in top position, phases in bottom position. So this is the basic requirement when we are drawn the Bode plot. And how can you draw the Bode plot for a given system? For example, the given system is 10 by s into s plus 2 into s plus 4. So for example, this is the problem. Draw the Bode plot for 10 by s into s plus 2 into s plus 4. Now I want to draw the Bode plot for this one. So this can be split into the different parts. That means, how can you split this given problem? 10 into 1 by s into 1 by s plus 2 into 1 by s plus 4. Now initially I want to draw Bode plot for 10 and draw the Bode plot for 1 by s and draw the Bode plot for 1 by s plus 2 and draw the Bode plot for 1 by s plus 4 initially, and combine all these things. Actually the function is multiplication, 10 into 1 by s into 1 by s plus 2 into 1 by s plus 4. But in Bode plot all multiplications are converted into the additions, so that the Bode plot for the 10 adding with Bode plot for the 1 by s adding with Bode plot for the 1 by s plus 2 adding with Bode plot for the 1 by s plus 4, then we can finally get a combination of these three Bode plots is nothing but final Bode plot, that is the Bode plot for 10 by s into s plus 2 into s plus 4. That is the technique to draw the Bode plot. So the given problem can be split into the parts and draw separate and combine it together. Then we can get the final Bode plot for a given function. So how can you draw the Bode plot for individual parts? So that the rules and regulations are required to draw the Bode plot. So in next video I explain the rules for the Bode plot. It's a very important. If you know the rules of the Bode plot, combining all these things, we can get the final Bode plot of a given problem. So that the rules for the Bode plots are very important. That means the next video is very important if you want to draw the Bode plot for a given problem.